Okay, welcome to Infinita Conversation, folks. I'm Prady, your host, and today we are diving into something that's got me buzzing, like supercapacitors, right? It's not just any supercapacitor, next level one that claims to rival lithium-ion batteries. That's a tall claim, right? Joining me is Philip Martin, the CEO of Emtel Energy, and the company behind these pretty bold claims. Philip, welcome to the show.
Thanks, Prady. We're excited to be here and ready to dive into your questions.
Great, great. All right. I mean, let's get straight to it. Supercapacitor have always been that tech where people go. Yeah, they can charge fast, but they don't have enough juice to compete with the batteries. That has always been the case, right? But you're saying here that you have cracked the code, 460 watt hour per kg. That's insane. I think a lot of people asking the same question to you, right? How real is it?
Oh, it's real. And, the secret is actually with our graphene, our solid state modules. Uh, by leveraging the conductivity and surface area, we're able to push supercapacitors into energy densities previously thought to be impossible. And we're going even further than that. So 460 is just the place we are today. We're going to get even better. We focused on combining rapid charge, discharge benefits with also long term energy storage, which makes this a little different than what you normally see with supercapacitors. So now our modules act very similar to batteries.
So, I mean, graphene, you mentioned graphene, right? Now, whenever somebody mentions graphene, they also mention scaling, right? So, I mean, and how you can, after all, it is like one atom of carbon, right? That is the thickness we are talking about. So, how can you scale affordably? That is the question. How are you making it work?
Well, graphene scalability has been a hurdle, but we solved it with our proprietary manufacturing techniques. So, and it is proprietary. I mean, we keep it secret, almost like Coke keeps their formula secret. Our methods have been able to reduce our costs, and while we still maintain material quality. So now we're deploying systems very near the cost of lithium, even with the lower cost that you see on the market today. So this is what makes us commercially viable, and which has made our storage very popular this year.
Hmm. So you have solved you're saying that it is cheaper at the end of the day. You are able to scale it to a pretty large scale.
Yes, and by minimizing waste and using less energy compared to lithium-ion batteries, we can actually make one of our modules a lot faster than you would produce a lithium-ion battery. And then when you take into factors like 500,000 charging cycles versus around 6,000 for lithium, our capex may be a little bit more, but opex wise, we are a lot cheaper than lithium.
Hmm. Okay. So I mean that is one thing, like scaling is one thing, but there is nobody wants to get away from what they are using, right? There is entrenched system, right? So durability angle is pretty wild. So then there is a like for the lithium ion battery there is a whole $1 billion infrastructure that has been built. There is supply chain. How do you break through that kind of momentum that has been kind of gained for a lithium ion battery?
Well, I think the primary point, I mean, it's been on the news for the last few months, all right? It's around the safety of lithium. And I think everybody's very concerned. Even if you go back and look at, the Lebanon fiasco with Hezbollah and how they blew up these phones and these pagers.
Hmm.
So when you start applying that same theory could happen in EVs and in these large battery energy storage, so the one thing that everybody's really concerned around is safety. So safety and then durability, systems that can really last and not have to be replaced. So
Mm.
you take the fact that our systems are very safe. We don't have the
Mhm.
risk of thermal overrun. We have no heat signature. We can operate in a wide range of temperature range. They start looking at those features versus, hey, look, I can get something safer and more durable than potentially with lithium.
I mean, safety has been always a concern, right, with the lithium-ion battery, thermal runaways, and we have plenty of horror stories. There
Yep.
was a Cybertruck that sort of burst into flames, and that was
Yes.
like hard to watch. There are a lot of stories, a lot of videos in the social media about that. But I wonder if there are supercapacitor have their own sort of skeleton in the closet. Um, what do you think
No, I
about it?
mean, no, I mean, actually, we have a lot of use cases. We had a system recently that caught fire at a tower caused by electric short circuit. Our modules caught fire, and they actually put it out with the regular fire extinguisher. And what was even more amazing was the module that burned was still able to produce electricity.
Hmm, that's impressive. I mean, that's impressive. I mean, that is reassuring. Like I think that alone is a very big point. That when people are driving a car or anything to do with the batteries, they worry about it. And I think a lot of other manufacturers worry about it because when you have safety issues like that thermal runaway and blasting, um, it is pretty bad. It looks pretty bad for a lot of smaller players will wipe out with that kind of thing. So that is very reassuring. But just coming back to the technical side of it, like there is capacitor, right? There are two plates, you have surface area, but then there is electrolyte. There is dielectric material in between them. So when you are claiming something like 460 watt hour per kg, I believe it is not just graphene that is increasing the surface area. It is something to do with the dielectric material as well, right?
Yeah, well, absolutely, the dielectric plays a huge role.
Mm-hmm.
But we've actually developed advanced solid state electric dielectric materials to optimize our energy storage, and these materials enhance the capacitance while maintaining stability and safety. It's
Mm.
about finding the synergy between graphene and these dielectric for maximum performance. So very, very efficient. We have the most efficient module or energy storage on the market these days.
So, I mean, there is something happening also dielectric wise. Like you have that secret sauce as well, right?
Right.
That it is not all the graphene. Um, I mean, if you have just the same dielectric that is commercially used, I don't think the graphene alone would get you there, right?
Right. Yeah. I mean, our engineers are amazing, and they make these components work in harmony. So in fact, even the systems that we have out there, the minimum amount of maintenance that you have to do on these, because
Hmm.
everything just works together so well.
Hmm. Cool, cool. No, I think if it is working, that's proof is in the pudding, right? If it is working commercially, I think you have sold a number of unit, bigger, larger unit, and I think you are very smart about it. So that is a proof, pretty good proof. Uh, so in terms of commercial use, right? Where do you see this is making the biggest splash? EVs, grid storage, or something else?
Well, EVs and grid storage are definitely obvious areas. I mean, we are working toward EVs. I mean, the standard to get into electric vehicles is very difficult. But right now, we're definitely we cut our teeth in the telecom industry, powering 3G and 5G towers, where we phones are essential these days. So having access, I mean, making sure you have a signal is always very important. So we're working with large telecom providers, and tower owners to provide power. Also, the data center industry, the UPS or the backup power for UPS, I mean, for data centers is humongous.
Mm.
Where, we just got through talking to a data center owner operator, and some of these new server towers takes 1 megawatt of power to keep them cool. So
Yeah.
you imagine the amount of power that needs to back up these systems.
Yeah.
And then of course, I mean, everybody wants to, they want to get off grid, right? Especially in California, where PG&E has had their difficulties. Being able to perform your own microgrid by only using solar in our energy storage, because we can last long duration versus having to couple up with a generator or something else, has made popular. We're doing a project in Northern California now to take an Indian tribe completely off grid.
I think that's a very big concern. I was talking to someone in Houston, and 2 years back they sort of had a pretty big power crisis. So that is a big thing, like how the backup energy. I think that we will see everywhere. Uh, these are pretty data center are very power hungry, as you said. And there are more going to be built. DeepSeek came, and they are gonna reduce the amount of data or the need for the data center. But still, I feel that the amount of data that is being generated every day and the processing need would just keep growing. So this is a pretty good direction I think you guys are going in. So when I think about lithium, and I think nobody here, when they think about lithium, it is like ions moving, and lithium ions are moving, and that is one thing. But then there is nickel, there is cobalt, there are there is magnesium, manganese, right? There are number of metals, number of elements, and the lithium is kind of a mess. Like it's mining of all these metals, and is just a mess right now. So when you're talking about supercapacitors, what is the sustainability angle to it? Like how does it compare on the sustainability front?
Well, we definitely don't have to worry about the mining of any cobalt, lithium, or any toxic mining at all. We actually make our graphene synthetically, so I mean, we don't even have to mine for the graphene piece of it. Our systems are 100 recyclable, 80% biodegradable. The only part that isn't is the plastic that's used to make the housing for our
Hmm.
modules. So when you talk about sustainability, and then talking about a product that lasts as long as ours, and then at its end of life, that you can just recycle it. Yeah, it's a big advantage over, especially the cost of even recycling lithium these days.
Hmm. That's a strong pitch. I have to give it to you. But let me just throw another wrench in here. So, somebody like Tesla or some other big dog here, right? What stops them from saying that, hey, we are just gonna buy your idea and mass produce it ourselves, right?
Yeah, I mean, actually, we when we our initial IP, we actually IP'd it, but we realized that we gave everybody the secret sauce when you did that.
Hmm.
So, in fact, we took the more Coca-Cola approach and made it a trade secret, right?
Hmm.
Kept the trade secret in house. Even today, whenever we were making our graphene, our synthetic graphene, we would have 5 different companies make the chemicals required to mix together to make that graphene to keep it secret.
Hmm.
Now we're moving all of that in house, but we've our engineers have spent many years perfecting all of this process,
Hmm.
and even when I mean, a year ago when I walked through the factory, you could go through R&D, and even now they've even locked it down even more. So to really protect this our product.
Hmm. Wow, this is pretty good. I really enjoyed this conversation. Any last words for our people who are listening here?
Yeah, I would say don't let the old energy storage standard hold you back. I mean, the one thing we've heard over 3 years of marketing the material is this sounds way too good to be true. But it's here. And our biggest thing is letting people know that it's available and that you have a solution that not only can compete with lithium, but is even better than lithium. So we are excited about introducing this to the United States and to the world. And we tell everybody keep an open mind and understand that we have a solution that can really make renewables work for them.
I mean, all the good luck. I think last week I learned about DeepSeek. It has been available since November. But DeepSeek actually showed what you just said, right? That big companies who have locked down technologies and they have billions of dollars doesn't mean that there is not a way that something new and exciting exists which can just blow their mind. So DeepSeek developed something at a fraction of the cost, at using very low cost servers, what OpenAI was not able to do with 45 times the cost. So I'm all for this. I think small teams doing great innovations like yours, um, um, can change the world, can bring very breakthrough technologies. So, to our listeners, stay curious, stay skeptical. I think that is one thing which is kind of getting bad names. And we'll catch you next time. Thanks a lot, Philip.
Thank you. You have a good one.
Okay, so this is good. This is great. I think we we spoke. I hope that we spoke our mind. So appreciate that very much. And I
I
will
think
see you.
you were right. It kind of flowed better after we started. So really good.
Yeah, it looked good. And maybe we'll see if there is something else we can talk about. I want to talk about actually a little bit more about supercapacitors. I don't
Okay.
know. We'll see what we'll put this thing and then we'll think about it, what we can talk about without sort of revealing too much
Okay.
about, or I mean, the impact of, some concept that you feel that is useful, like impact of AI on the material discovery and all that. When you were going through this R&D process for supercapacitors, there was a role of AI in this? I don't know.
No, I mean, afterwards, we've implemented AI into our energy management system to manage the power, right? Which is, I mean, it's kind of groundbreaking being able to have AI determine, the best time to charge, the best time to discharge, when do we pull from these other power sources? Yeah, so we've implemented that piece into our energy management system.
Hmm. So maybe we can talk about it. I was talking to another CEO. They are they hold a number of patent on serial charging. Whether I don't know whether you know the serial charging. So basically, in EVs currently they have batteries, right? And it is pure that there is an electric motor which is run by EVs, right?
Right.
The run by the batteries, right? So, but there is an interest in reducing the number of batteries to 20% less, say, because it reduces and then connecting it to a generator. So there is
Right.
if you look at ChatGPT or somewhere, serial charging versus parallel charging. So there is a lot of interest in keeping the electric motor, keeping the batteries, 20% of them, and then behind that putting a generator, gas generator. So basically, gas will be used to generate and charge the 20% of these batteries, and
Okay.
then that will run electric motor.
Okay.
Right? Now there are certain advantage to it. The electric motor is like 97% uh, um sort of 97% efficient,
Okay.
and it does very good pickup and other things. So, but it will be a gas generator. So car would be gas car, like you can fill it up, but then it will run like it will take advantage of the electric motor, and that would be a very, very good system. It has been found that people are going in that direction. Now with the car, it not only it will be good for the car, but also it is great for the planes, electric planes. So electric planes have not come up, right? So the thing is with the electric plane is that this kind of hybrid system can come where they are charging batteries, a small amount of batteries with the thing. So it will be light, first of all. Second is that a lot of runways require short kind of takeoff.
Right.
So this will, since electric motor does a very good takeoff,
More torque.
this will be, yeah, more torque. So basically, it's very ideal system for that.
I can see that.
Yeah. So this is a very clever system
Yeah.
that is coming up. I wonder that there is something for supercapacitor there, you know.
Pretty sure we'll be involved in all of that eventually. Because if you're gonna anything you want to do with batteries, I think what people are starting to see is the safety concern around lithium, right? More and more. I mean, New York has already banned it inside the city. Chicago's already banned it inside the city. California is very reluctant to adopt it. The military already said no.
Hmm.
They don't want any lithium near any one of their bases. Uh, and so, if you're going to put it into a plane or any type of moving vehicle, you want something that's safer, right?
Hmm.
Especially in a plane. I mean, they already, you hear it already. If you're putting your baggage up underneath the plane, don't have lithium batteries in your bag, take them out, and it's for that reason. And I have a feeling we'll play a major role in that. And as things progress and more people get, I mean, they become knowledgeable on what we have.
Hmm. No, I think this is a great groundbreaking technology, and I mean I was thinking a lot about it, like how the lithium ion is ion moving basically. It's a dirty process. Um, in the case of you know, so I think capacitor suffer from a specific energy, like low specific energy. So I think you have solved that problem, and supercapacitors are much cleaner. Just you you have charge that comes on the plates and then it goes back. Is there any kind of part that sort of gets bad after a certain time when you're cycling? What
I
happens?
mean, some of the electronics,
Hmm.
right? I mean, there's electronics in the BMS, but that is it. Even that's pretty stable. But that if there's any weak point, I would say it would be that.
Hmm. Electronics, basically, right?
Yeah.
But I mean, when they see this kind of stuff, probably Elon Musk type people, they would see this thing, they will say that, okay, maybe the volume wise, it is pretty large supercapacitor. Is this like, volume wise, it is the same volume, it is taking the same space as the batteries?
Actually, we became less. I mean, I heard from my team today. So right now, we have a 7.1 kilowatt micro module. It's about the size of the modules, the lithium batteries you would use for the towers. But
Hmm.
they've increased the density that now today, in fact, they told me they have it. I can't sell it yet, but they have that same module is now 15 kilowatt hours. So they've doubled the energy storage in the same amount of space.
Great. Great. Well, let's talk about AI, the use of AI in whichever way you have done. And, that would be another great piece. Everybody is talking about AI. Everyone is talking about the underdog, DeepSeek. So this will be another, DeepSeek for the batteries, right?
Yeah.
Uh, do you go to any conference here?
We do. I mean, I've been busy. We're kind of focused on just the larger ones. We're going to do RE plus. My team just sent me another one. They want to do out in San Diego here end of February, I think it is. Uh,
RE1. You said RE1. I'm not very familiar with it. I try to, I'm looking.
RE plus is like the largest renewable energy show in the United States,
Okay.
and they flip flop. Last year it was in LA. This year it's going to be in Vegas.
Okay. Both of them are pretty close to me. So,
So the last one I went to 2 years ago, because last year I was traveling, but the last one I went to they had 29,000 visitors.
wow. And
Yeah,
RE
that's
plus, RE plus is when is that? Do you
I
know?
think it's in September.
September.
We're planning
So,
on doing a big show, a big showing. Um, yeah, I mean, even having a display of our 40-foot container in there with everything to show people the modules, everything, our residential solution, all of the stuff that we have to offer.
see to believe it.
That's
Would
exactly.
you would you shock them as well?
No, we won't shock them. But the thing is that we'll also be able to point to the actual projects that we've started in the U.S. So that's
Hmm.
what everybody wants to see. Have you done anything? And so we are, and we by that time we'll have done several projects.
Hmm. And what else you were saying that
The other one I can't remember the name of the show. I'll have to go look it up, but it's in San Diego, end of February.
okay, San Diego and where are you based out of?
I am in North Carolina. Near the Research Triangle Park, so near Raleigh.
Ah, near Raleigh.
Yeah,
Okay, cool, cool. Yeah. Great. If I decide to come over the Feb end one, and you decide to come over too, then San Diego is also pretty close.
yeah.
So, and then we'll meet as well.
Okay.
But next time we meet, I think we can, even before that, maybe February sometime, we can do this AI optimization, I think software optimization that you have done,
Okay.
and how you have used the AI to sort of make a system. Anything else you want to talk about?
Um, I mean, if I think of something, I will let you know. I'll ring you. I know this next few weeks is a ton of travel.
Okay.
'Cause I think I got to head to California, then Alaska, then back to
Alaska.
Texas. Yeah, we because we work well in the cold and they need energy storage. So this is a great solution for them.
Oh yeah, and batteries don't work very well in the
They
cold,
don't work well in
and
the cold.
also not very well in too hot,
Yes.
right? So I'm just surprised that there is nothing from Elon Musk on this.
Well,
Uh,
he did put liquid cooling on his lithium batteries, so that was their innovation.
there was a discussion with BYD on the CEO of BYD. I have seen with Elon Musk. And the guy said to Elon Musk that you are not a battery engineer. We are far ahead of you. So even in battery, I think he's getting a beating. But I'm not. I mean, I'm talking about that he is not paying attention to supercapacitor. Uh,
I mean, he did his graduate study on supercapacitors, so he definitely knows about them. I think that the more noise we make, the more we'll catch his attention.
hmm. Because he would be sort of like he will catch it. And the thing is that that would not be a good thing because he is a guy who would just listen to you, or he wants control over everything. So that
Yeah,
is why what I heard.
but he'll pay 8x for it. So he'll make it worth your while. Definitely.
Yeah,
So,
that is so I mean I have heard about like glasses because I used to work with glass company. So I mean maybe I'm wrong. Many times I'm wrong. So but in the glass company he did a lot of like discussions for Cybertruck and for glass for that. He learned everything and then sort of like said I would just make it myself. So that sort of thing. So
this
it's
would be
always
very
kind
difficult. This would be very difficult for him to do, though.
yeah, yeah, you're right. It is much difficult to do than just the safety glass on cars.
Yeah, yeah,
So, and with a person like you, like there are a lot of trade secrets.
definitely a lot, a lot.
Cool,
Well,
cool,
Prady,
Philip.
I definitely appreciate it. I know I need to go jump and try to get some more stuff caught up before this day ends for me. And but we will connect again, and we'll see what we can discuss next time. Thank you so much.
Thank you, Philip.